Hello, good morning, sir. I am Param Prakash. I am going to give you the presentation for STEAM seminar on topic Huffman coding algorithm and its application. I will give you the introduction of Huffman coding algorithm. In 1952, David A. Huffman, the student of MIT, discovered this algorithm during work on his term paper assigned by his professor Robert M. Fenno. The idea came into his mind that using a frequency sorted binary tree we can able to find out the most efficient binary code. Huffman denied the measure flow of Claude Shannon Fano coding by building the tree from bottom up instead of from top down. There is a lot of compression algorithm, but we focus on lossless compression. So in this regard, Huffman algorithm is so cool and efficient algorithm in sort of smallest application. Huffman use for image compression, for example PNG, JPG for simple picture of word. It also use MPEG whenever you watch movie or video in computer. Chances are that its image will be in MPEG format. Both these PNG, MPEG and for text compression, for example static and dynamic Huffman coding techniques. Huffman coding is a lossless data compression algorithm. The idea is to assign variable length codes to input characters. Length of the assigned codes are based on the frequency of corresponding characters. The most frequent character gets the smallest code and the least frequent character gets the largest code. The variable length codes assigned to input characters are prefix codes, means the codes bit sequences are assigned in such a way that the code assigned to one character is not the prefix of code assigned to any other character. This is how Huffman coding makes sure that there is no ambiguity when decoding the generated bit stream. Now I am handing over Tikam Singh, and from now he will explain the further algorithm.
Good morning, sir. I am Tikam Singh. Now I will continue the topic from here. As Paramprakash said, this is data compression algorithm. So I will explain how this algorithm works with an example. So I am taking this string for example, and we want to send this string onto the network. And as we know, each character takes 8 bits, that means 1 byte. So this string will require 15 bytes, that means 120 bits. But we can reduce the size of this string by using Huffman coding algorithm. And for that I will explain how this algorithm works. First of all, Huffman coding creates a tree using the frequencies of the characters and then generates code for each character. Once the data is encoded, once the data is encoded, it has to be decoded. Decoding is done using the same tree. I will explain further how decoding is done. So, Huffman coding prevents any ambiguity in the decoding process using the concept of prefix code. That means a code associated with a character should not be present in the prefix of any other code. The tree created above helps in the maintaining the property. Here we will calculate the frequencies of each character present in the string that we have taken for an example. So here frequency of frequency of character B is 1 and character C is 6, and for character A it is 5, and for character D it is 3. And then sort the frequencies in ascending order. Here 1, 3, 5 and 6. After making the sorting, make each unique character as a leaf node, and then create empty node Z, assign the minimum frequency to the left child of Z and assign the second minimum frequency to the right child. Here we have done the same. Here this is the minimum frequency and this is second minimum frequency, and minimum frequency we have taken to the left side and second minimum frequency we have taken to the right side, and then we will do the sum of these two frequencies and will take it as a node, take it as a root. So here 1 and 3 it uh, and sum of these two is 4, and then remove two minimum frequencies from queue, priority queue, and add the sum into the list of frequencies, and then again insert node Z into the tree, and then we will repeat step 3 and 5 for all the characters, and finally we will make a tree with the same procedure. Here we have made the tree by enqueuing two elements for each node, each leaf node we will assign 0. That means for the left side we will assign 0, and for the for the right side we will assign 1, because we want to decode these code in 0 and 1. So we are assigning 0 for the left and 1 for the right side. For sending the our string to a network, we have to send the tree as well, because if we will not send the tree, then decoding cannot be done without using the tree. That's why we have to send the tree. We have to send this. We have to send the tree and this table. Now I will explain how decoding is done. For decoding the code, we can take the code and traverse through the tree to find the character. Let 101 is to be decoded. We can traverse from the root as in the given in the figure below. So, if we want to search for the D, here it is D, character D. So, we can start from the root, then go towards the D. So, now 15 to 9, then 4, then D, and we can see here it is 1 and then 0 and then 1. So code for the D character is 0 1 0 0, sorry, 1 0 and 1, and similarly we can find for A, C and D, B. For A, the code will be from 15 to 9, then 9 to 5. So the code will be 1 and 1. And similarly for C, code will be 0. And for B, the code will be 1, 0 and 0. And we have also given in the table code for the A. It is 1 and 1. Here we can see this is 1 and 1, and for B it is 1 0 0, and for C it is 0, and for D it is 1 0 and 0. And size, after reducing the size is given here, and we have 2 bits and its frequency is 5, so total there will be 10 bits. And similarly here are 3 bits for this character and its frequency is 1, so its size will be 3. And similarly for this 1 bit and frequency is 6, so there will be size 6. And for D there are 3 bits required and its frequency is 3, so there will be 9 bits required. So the total bits required will be 28 bits. That means from 120 bits we have reduced the size to 28 bits. This is how uh, Huffman coding reduced the size of the string. And I have explained the decoding of the uh, encoded algorithm, so we can send it to the on the network. And now I would sum up all the steps, and I have written an algorithm for that. So first of all, create a priority queue consisting of each unique character, then sort them in ascending order for their frequencies. For all the unique characters, create a new node and extract minimum value from queue, and then assign it to left child of new node, extract minimum value from queue, and assign it to the right child of the new node. Then calculate the sum of these two minimum values and assign it to the value of new node insert, and insert this new node into the tree return root node. So the same that I have explained in the algorithm, I have done in the coding, and that's how I have ended my presentation. Thank you, sir.